Today we're going to talk about arithmetic sequences and series. This entire unit is about sequences and series. The difference between those two, a sequence is just a pattern, where you would maybe be asked to find the next term in the pattern, figure out how you get from one term to the next and continue the pattern on, or maybe even tell me a term that's 50 spots down the line, something like that. A series is a sum. So if you take the terms in the pattern and add them all together, then that's changing a sequence into a series. So we'll see applications where sometimes you just need to know one number in the list, and sometimes you need to know the sum of all the numbers in the list. Arithmetic, and it's not arithmetic, it's arithmetic. The stress is here. I'm not sure how I indicate a stress in English, but arithmetic sequence and series. What that means is we add the same number each time. So, for example, an arithmetic sequence, 3, 7, 11, you can see the pattern. I'm adding 4 each time. And you can continue that arithmetic sequence. So these are nice, neat patterns. You just add the same thing every time. Nothing fancy as far as the pattern, how you get from one term to the next. There's a lot of interesting patterns, more interesting than this, but this is one that has a lot of real-world applications. The series counterpart would just be replacing those commas with plus signs. So for some reason I need to add up some terms of this series. I can do that and we'll get a formula for each. So that's the difference between a sequence and a series, and these are all arithmetic because to get from one term to the next you add the same amount. Okay, so these, I'm using some vocabulary. These are called terms, and sometimes these will be represented with the letter A, sometimes they will be the letter T. In our textbook we use T for term. There's a formula sheet you'll use on your end of course exam. I think it uses T as well. I'm not positive, but just realize this could be A or T. So, T1 is your first term. T2 is your second term, and so on. All right, so for this first sequence, T1 is 3, T2 is 7. The little subscript 1 or 2 is the place in line. As we do these formulas, sometimes we'll need a generic place in line, the nth term, that would be Tn. So if I wanted to add up 20 terms, then Tn would be T sub 20, something like that. We'll see how that plays out in just a minute. N is your number of terms, or your place in line. D is called your common difference. And this is the number that you add each time. And keep in mind, this is defined as what you add. So if this were a sequence that went 19, 15, 11, 7, then D equals -4. It's easy to look at that and say, yeah, I know they're off by 4 each time. There's a difference of 4, so the common difference is 4. But the definition is what you add, and subtracting is adding a negative. So that's just a technicality that will help you when you do formulas. So let's see. We have, I think that's all the terms we need right now. There are 2 main applications of sequence and series. If you want to know, we'll keep this same, we use this same pattern from above. So let's call this A. This is our first big application. And this is find any term in the list. All right. I know that the pattern starts out 3, 7, 11, 15, 19, and you could keep that pattern going for as long as you wanted to write it down. But what if I want the 3,728th term in that list. I would like to do that without having to write down all 3,728 terms. So we have our first formula. Here it is. T sub n, which is any term in the list that you wish to find, is equal to T sub 1. So you got to have a starting point. We're starting at 3 in this case, plus, and I will explain this after I write it down, plus n minus 1 times d. So think about it. If you want to get to the 100th term in this list, you need to start at 3, and since you're already at the first term, you need to take 99 steps to get to the 100th term. So this n minus 1 is your steps. And remember, we just defined d as the common difference. This is your step size. So if you multiply your steps by your step size, that's how much you increase, or if it's negative, that's how much you decrease to get from your starting term, T1, out to the term you're looking for. So let's take our same example, which was 3, 7, 11. Let's find the 283rd term. Fair enough. It doesn't matter how big the 283 in this case is. You can find the 8 millionth term, and it will be just as easy because of this formula. So what we're looking for is T283. That's equal to our starting point 3 plus 282 steps, each step being size 4. All right, it makes a lot of sense. I like this formula because it's very logical. If you want to get to the 283rd term, starting at the first term, you need to take 282 steps, each step being size 4. So, pardon me while I calculator. 3 plus 282 times 4. And your calculator, if you're using a graphing calc, should have order of operations. You can just type that in one step. This is 1131. So the 283rd term in that list is 1131. No big deal. All right, so let's talk about second big problem type, B. The sum of, let's just call it a bunch to be generic, a bunch of terms. So what if I needed to add up the first 283 terms in the list? All right, it wasn't enough for me to just know that what that one last one was. I needed to add it up. So, for example, I need 3 plus 7 plus 11 plus plus all the way out to the 283rd term, which happens to be 1131. So we can talk about this formula. There's a cool story behind it. I'll tell you in class, but here's the formula. N over 2 times T1 plus Tn. So if you have an arithmetic sequence or arithmetic series and you want to add it up, you need to know 3 things. You need to know how many terms you're adding up. You need to know what's the first one and what's the last one. If you know those 3 things, you can add up the series. So let's do that for this example. The sum, big S is the sum, and little 283 tells me how many terms I'm adding up. You know, from 3 to 7 to 11, all the ones all the way up to the 283rd term. It's 283 over 2 times the first term plus the last term. It doesn't matter, you don't need to know all those terms in the middle. All you need to know is the first one and the last one. So if I take 1131 and add 3 to it, I get 1134. If I multiply that by 283 and divide by 2, I get 160461. All right, so our 2 biggest applications. What's the 283rd term? I have got one formula for that. So make sure that you have definitely noted this formula. This is our arithmetic sequence formula. All right, that's just to get terms. And this is our arithmetic series formula. So with those 2 big ideas out of the way, there's a couple of different ways I could ask you this question. One way the official name is finding arithmetic means. And the unofficial way is you're going to fill in the blanks. You know, what if I start at 11, and this case I'm going to have 3 arithmetic means between 11 and 90. All right? Basically, what do you need to add so that it evenly works out to get from 11 to 90? Now, there's a couple of approaches. I'll do both really fast. Approach number 1 is this. Use the formula. Use your arithmetic sequence formula. Pn equals T1 plus n minus 1 times d. Basically, I end up at 90. I started at 11. N minus 1 is my number of steps. 1, 2, 3, 4 steps. Or you could think of that as 90 is the 5th term, so 5 minus 1 is 4. And d is my unknown. So let's solve this equation and figure out what d is. Well, 90 minus 11 is 79. So if I divide 79 by 4, I get 19.75. So that's the number that I need to add each time. So my arithmetic means are 11 plus 19.75, which takes me to 30.75. Sometimes they'll work out nicely, sometimes they won't. Plus another 19.75 takes me to 50.5. I should be able to add this without a calculator, but I don't trust myself. Plus 19.75 is 70.25. And then another 19.75 would take me up to 90. So it worked out evenly. The other option, which kind of does the same thing but just more informally, if you need to go from 11 to 90, you need to increase 79. How many steps did you do that in? Well, 1, 2, 3, 4 steps. So I need to take 4 steps that it increased me 79. So I'm kind of skipping right down to this part of the equation and dividing by 4 and getting the 19.75. So whether you want to do that formally or informally, we get you figure out that it's that common difference d is 19.75. By the way, the middle of the arithmetic means, that's just the mean of the two numbers. You know, a mean, an average, add them up and divide by 2. And you get the middle. You could actually kind of do that all the way through. You could do 11 plus 90 divided by 2 and get the middle number. You could do 11 plus 50.5 divided by 2 and get the other, you know, the middle of the smaller half. You could go with that approach. All right, let's do one more variety of question style. Like this. How about this? First term is 126. Common difference is -4. Find S48. So what I'm asking you for is start at 126. The next term is 4 less than that. And I want to add up the first 48 terms of this series. This is a series question because I'm asking you for a sum. Now, you need to know 3 things to add up a sum. You need to know the first one, the last one, and how many there are. Well, I know the first one. I know how many there are, but I don't know the last one. So what you have to do in a situation like this is step back and use the sequence formula to figure out the last one. This is a classic combination of the two formulas. Your first term plus n minus 1 times d is going to give us our 48th term. 126 plus 47 steps, each size -4. And that gives us 126 plus 47 times -4 is -62. And then you can use that to find the sum of the first 48 terms. 48 over 2, number of terms divided by 2, times first term plus last term. All right, and the formula applies whether they're positive or negative. If I take my -62, add 126 to that, multiply by 48, divide by 2, I see that my sum is 1,536. So in this series, some of the terms were positive and they transferred over to the negatives, so they were actually taking away from the sum. But overall, the formula still applies. All right, so two big formulas, both highlighted here. This is the series, arithmetic series. This will add up as many terms in an arithmetic series as you want. And before that, we have the arithmetic sequence. This will give you any term in the list. And sometimes you might have to use both to answer a question. All right, so that is it for arithmetic sequences and series. This is a good chapter. We've got a lot of fun patterns to look at. These are just kind of some of the basic ones. So, Young out. See ya.